Okay, so at the end, so when we were talking about that cell cycle, we had said during G1, we had said we had this, the two full sets of chromosomes, and we had said that one set went to this daughter cell and one set went to that daughter cell. And we had said in G1, all the cell was doing was getting a little bit bigger and producing more of the cellular organelles. And then during synthesis, that's where we made that second set of chromosomes. So we had 23 pair, 48, or 46, 23 pair of chromosomes, and that's 46 total. And so we'd said during synthesis, we've got to make a copy of each of those 46 different chromosomes. So when we look at prior to synthesis, we can see this is what a chromosome might look like when it was coiled up. And this is what we would call a chromatid. I know there's a lot of words, so I'm going to write that up here. Chromatid. One chromatid. And then we said though, during synthesis, we made a whole nother copy of that. And then during G2, even, after synthesis during G2, we had a whole second copy of each of those 46 chromosomes. So in order to keep all that from getting just completely mixed up, it ends up that every one of those chromosomes are connected to their copy by a centromere. So after the S phase, you have this centromere that makes that one stay close by connecting the two of them as at the centromere, and then we're going to call each of these two copies a sister chromatid. I know. So, and then what's going to happen, just sort of as a preview for the upcoming events of mitosis, like a TV show thing, right? You know what's going to happen? This thing is going to divide right here, and we're going to, so if you look at slide number 6, you can see where I'm going with this. We end up, those sister chromatids become daughter chromosomes, each one in a different cell. So if we're looking at the chromosomes, that's what's going to happen. Okay. So as a result of this, every animal has an even number of chromosomes. So we had said, you and I, we have 23 pair. That's an even number. 23 pair, that means 46. And where did I get them? Well, we haven't talked about meiosis without the T, that sex thing. But what happens with the egg and the sperm, you get half of, we said the 23 pair, you get 23 from dad and 23 from mom. That's 23 pair. That's how it works. That's how it all goes, how the world goes around. So for like chromosome number 1, you got one of them from mom and you got one of them from dad. And then chromosome number 2, one from mom, one from dad. Chromosome number 3, you get the picture, right? Okay, so we have 23 pair of these darn things, and they all have to be duplicated, and we said that happened during the synthesis phase. And after they were duplicated, the 2 copies of each one of those is connected together by a centromere. I'm flipping the slide. Okay, so we would say, how on earth are you going to get this sister chromatid that direction and this sister chromatid this direction? And I mentioned before, I said you're going to have like a rope connected to it. It's not a rope though. It's something, it's called a spindle fiber. It's a protein, but it's a protein that works like a rope, and it pulls one sister chromatid that way and one sister chromatid the other direction. And when did we say we make that stuff? In the cell cycle in G2. Spindle fiber, all of that kind of stuff was made in G2. Okay. All right. So we have the stages of mitosis. I'm going to draw a few pictures up here, so I'll be right back.